melting point, boiling point, and density. Yes. Generally, this melting point and boiling point depends upon what is meant by melting point and boiling point. When a solid converts to liquid, liquid converts to gas. For these two process, supplying heat or energy. Okay, at what temperature that takes place? At what temperature this takes place is called melting point, is called boiling point. Why you have to supply the energy? And the close packed molecule should become different. Yes or no? So to separate the two friends, some energy is required. Here more energy, they are thick friends. They are not thick friends, less energy. That's why less melting point, less boiling point. Yes or no? So melting point and boiling point is nothing but the temperature at which that solid become liquid and liquid become gas takes place. Is it correct or not? That means that melting point and boiling point are indirectly depends upon their attraction. Yes or no? Melting point and boiling point depends on attraction between the constituent particles. Here the constituent particles are ions. Yes or no? Melting point and boiling point depends upon the attraction between the constituent particle. So larger the attraction. So in ionic solids, strong, what is that? Electrostatic attraction is present. In ionic solid, strong electrostatic attraction is present. Strong electrostatic attraction is present. Okay. Therefore, high melting point and boiling points are present. Therefore, have high melting points and boiling points are present. That is why if you throw the table salt, it will be burst out. Is it right? That is why, because their melting point and boiling points are high. And you go for density. Why do they have more density? Because the ions are closely packed. While they are closely packing of ions. Why they are closely packed? Because of strong attraction gives high density. Yes or no? Density is equal to mass by volume. Close packing causes less volume, more density. Third point. Okay, I think you understood about the density and melting point. And next one is a hardness and brittle. That is third one. Ionic compounds are what is that? More harder and brittle. Why they are harder? Because of strong attraction. Okay, since strong attraction between ions, opposite ions. Okay, strong attraction between opposite ion causes hardness. Okay, why they are brittle? Brittle means when you apply force, they become easily breakable. Why do they become brittle? On external force, the layers shift one another. Okay, due to that, like ions mean positive, negative comes closer. Like ion comes front of each other. Okay, this repulsion causes brittlety or brittleness. I think understood. I am giving the reasons also. and fourth point. Okay, melting point, boiling point, density, and hardness and brittlety, and next conductivity, and next conductivity. Generally, ionic compounds, okay, in solid state, does not conduct any electricity, but in solution or molten state. Molten means their liquid state. Molten state conducts, okay, electricity. Why? Because since having free ions. Sir, why don't they conduct in solid state? Solid state, no free ions. In solid state, no free ions. Sir, already in salt, positive negative ion is there. No, in solid state, they are fixed. Madam, చెప్పండి. మేడం చెప్పండి. బాగున్నా మేడం. కాలేజీలోనే ఉన్నా మేడం. యాక్చువల్ క్లాసెస్ అంటే కాలేజ్ లైవ్ క్లాసెస్ ఏముండవు, బట్ పిల్లలకి అంటే ఆన్లైన్. Okay, sorry, yaar. I got a small phone call. I'm very sorry. Divit Reddy.
Sir, scroll up, sir.
Sir, I will send
Sir,
you the
scroll up,
notes.
sir.
Na? I will send you the notes, na? And number 2. While I am writing, where will you gone?
Sir,
What is the doubt here?
writing, sir.
Okay.
Sir, no,
So,
sir. Missed that, sir.
melting point
Okay,
and
sir.
melting
Okay,
point.
sir.
Is it right? And conductivity. Why don't they conduct? Why don't they conduct in solid state? Because of no free ions. All the ions are at fixed position. That's why they won't. What is that? Go or they won't move. That is the reason why in solid state they won't conduct. But in solution or molten or liquid state conducts electricity since having free ions. When they are in liquid or molten state, the free ions are releases. That is the reason why they conduct electricity. And next, what is that? Fifth one. Okay, these ionic reactions are very fast. Yes, 1 minute. Okay, next one, solubility. Next one, solubility. Sir, what is solubility? Okay, that means ionic solvents. Always you know in your school level, like soluble in like soluble in like. And what is the meaning? Polar solvents, polar substances soluble in polar solvents. Okay, our ionic compound is a polar substance. Non-polar substance soluble in non-polar solvents. Non-polar solvents mean like covalent compounds. Yes or no? So polar soluble in polar, non-polar soluble in non-polar. What is that? Solvent polarity. Who will decide the solvent polarity? Yes, polarity of a solvent. Okay, number 2, polarizing solvent. Yes or no? Polarity of the solvent decided by dielectric constant. Decided by dielectric constant. Sir, what is a dielectric constant? The ability of a solvent, to weaken the electrostatic force acting between the charged particle. Charged particles, and to dissolve in it. Okay, the ability of a solvent to weaken the electrostatic charge between the charged particle is called dielectric constant. For some ions, for some solvents and their dielectric constants. Solvent and the dielectric constant. Okay, solvent, water, solvent, methyl alcohol, solvent, ethyl alcohol, and the solvent, acetone, and the solvent, acetone, and the solvent, ether, that is diethyl ether. I am writing the dielectric constant values. 81, and that is 35. This is 27. This is 21. This is 4.1. Ante as the higher the dielectric constant, higher will be the dissolved. Higher the dielectric constant, larger will be the dissolution of polar solvents, polar molecules, polar substances, anything. So water having the highest dielectric, and water is the more polar solvent. So polarity of the solvent decided by dielectric constant. This is not required for our syllabus, even though I have discussed. Do you know why? In your throughout chemistry, most of the term we are using dielectric constant. Larger the dielectric constant, larger will be the polarity of the solvent. Okay, na? So as a dielectric constant increasing, polarity of solvent increases. Please remember that. This is the point. So like soluble in like. That is why most of the ionic compounds, because they are polar, most of the ionic compounds are soluble in water. Soluble in water. Why? Because of this reason, because it has high dielectric constant. Higher the dielectric constant, more will be the solubility. And next point. I'm going for the next point. That is isomerism or space isomerism. Space isomerism. A student. What is the space isomerism? Already I told you, ionic bonds are non-directional. Why? Because one Na plus is attracted by 6 Cl minus. One Cl minus attracted by 6 Na plus. No direction. Is it right? Is it? Are you remembered or not? In Na plus, Cl minus, Cl minus, Cl minus, Cl minus, Cl minus, Cl minus. Each Na plus surrounded by 6 Cl minus. But which one attracts perfectly? We can't say. All of them equally. So non-directional. Therefore, whenever direction is there, they can show isomerism. Due to that, ionic compounds does not show space isomerism. Yes, this is the reason. Next one. Okay. Next one. Seventh one. Isomorphism. Sir, what is isomorphism? Okay. Different ionic compounds having. So to show isomerism mean they have same molecular formula but with different arrangement. Isomerism mean same molecular formula, different arrangement. So isomorphism, different ionic compounds having same charge, same configuration or geometry of ions are isomorphs to each other. Shall I take one example? What is that? ZnSO4 7H2O. Number 2, FeSO4 7H2O. Both are having same configuration. Zn plus 2, Fe plus 2, SO4. Their geometry same. Their number of why? Their coordination same. Their charges same. That is called isomorph. Another example. Alums. What is the alum general configuration? M2SO4, M dash SO4 taken thrice, 24H2O. All alums are isomorphs to each other. Why? Because every alum is a +1 charged cation. This is a +3 charged cation. Example: K2SO4, Al2SO4 taken thrice, 24H2O. Potash alum, K2SO4, Fe2SO4 taken thrice, 24H2O. These are isomorphs to each other. Why? Because aluminium iron +3 charge, potassium +1. Is it correct or not? This is called isomorphism. And next, last one. Ionic reactions are very fast. Ionic reactions are very fast. Why do they? Because since free ions are involved in the reaction. Sir, if ions are involved, why is it fast? Let us say example. If forms H2 plus Cl2 gives rise to HCl. and this is a covalent molecule. And a hydrogen bond first should break, Cl bond should break and form HCl, and a bond breaking and bond makings are required in covalent reaction. But in ionic reaction, for example, you are taking aqueous AgNO3, you are taking aqueous NaCl, readily form a white precipitate within fraction of seconds. Okay, why? Because there is a free Ag plus and NO3 minus. There is a free Na plus and Cl minus. Readily takes these two because of ions involved in the reaction. No bond breaking, no bond making. Just it is a attraction between the ion. No bond makings, no bond breakings. No bond makings and no bond makings are required. That is why they are very fast. These are the some properties of ionic compounds. Okay, these are general properties ionic compounds. What are that, Nana? What is that? Their melting point and boiling point, their physical state and their hardness and their solubility and their conductivity, and what is that? Space isomerism, isomorphism, and their reactions. But students, these are also having exceptions. Now, for example, NaCl, NaI, both are ionic compounds. Both are ionic compounds. According to our discussion previously I have done, ionic compounds should be soluble in water. Why? Because polar and polar. But do you know NaCl more soluble in water? More soluble in water. But NaI more soluble in acetone. Why? You see, water has more polar solvents, but acetone is a non-polar solvent. Yes, non-polar or aprotic solvent, less polar solvent. Otherwise, less polar solvent, that is aprotic solvent actually. So sodium chloride is more soluble in water, sodium iodide more soluble in less polar solvent or aprotic solvent. According to my point, all ionic compounds are more soluble in water. But even though, why sodium iodide dissolves in acetone rather than in water? Why? Why? I can give my answer that all ionic compounds are not 100% ionic. Likely all covalent bonds are not 100% covalent. The answer for this is all ionic compounds are not 100% ionic. Due to the reason, okay, all ionic compounds are not 100% ionic. Yes. Why don't they ionic 100%? Okay, this can be explained by polarization. Why they are not 100%? Question: why don't they not 100% ionic? This can be explained by polarization, or polarizing power and polarizability. These all things are known by Fajan rules. Yes, our next topic actually Fajan rule. These Fajan rules are depends upon polarization. Polarization is nothing but polarizing power and polarizability. Why do they are interrelated, sir? Yes, if you know one by one, you can understand. So what is the thing I given? What is the thing I given? Polarizing power and polarizability. Let us say, here is a cation. Here is a, okay, anion. Cation and anion. Generally, cation and anion. Generally, which bond is present between cation and anion? Ionic bond should be present. Ionic bond only present. Should be, according to our thought, ionic bond only present. Should be ionic bond only present. But that is our wrong thinking. That is our wrong thinking. Now, this cation, okay, anion. In cation, protons are greater than electrons. In anion, electrons are greater than protons. And these protons having more charge to attract the electron. But these electrons are not easily attracted by proton. Why? Because in this one, proton number is less, electron number is more. That is why this positive charge attracts the, what is that, Nana? Electrons of adjacent anion. Already this was given. Even though given, my positive charge is more positive. Why? Because proton number is greater than electron number. This attracts the, actually in this one, electrons are symmetrically distributed around the anion. Anybody having the doubts? Yes, Yoganand Reddy.
Sir, once can you say the relationship between conductivity and size of the ions?
Conductivity and
size of ions.
Sir, conductivity and size of ion I have to discuss after this one.
Okay, sir. And
actually, if you want, I will discuss also. But actually, did you get in your what is that ion periodic table lesson?
Sir.
Periodic table lesson. Did you get it or not? Likita.
Sir, can you explain space isomerism once again?
Space isomerism. Generally, existence of same molecule in different arrangements is called isomerism. Actually, when it is possible, if there is a direction is present between the bond, it is possible. But no direction is present by ionic compound. That is why no space isomerism. All sides are always equal. All side attraction is always equal. Na plus around 6 Cl minus are there. All side it is equal attraction. There is no direction for the bond. That is why no chance to arrange a different way. Understood? Now, here the student asked the question is correct. What is that, Yoganand Reddy? But to explain that one, I required some other factors. Lattice energy, hydration, enthalpy. 2 factors are required. But if I explain that one, I will miss it this one. Okay. Anyway, we will discuss later, no problem. If 1 or 2 bits are missing, no problem. We have 25 bits more, na? Yes. What is hydration energy? Yes, I have to explain. To explain this one, I have to explain hydration energy. But meanwhile, I want to explain this point first. Cation, anion. This cation attracts anion. Generally, cation or anion are already bounded by ionic bond is there already. Even though my cation attracts this electron. Due to that, that anion was distorted and electron density is coming towards the cation. Sir, some students are getting down. Sir, is it this nucleus attracts this electron? No, this nucleus cannot attract its own electron. Why? Because Number of protons is lesser than electrons. Why? It is anion. Sir, why do you show anion is a big, cation is a small? Yes, student. Anion is always bigger than cation. Hello? Hello? చెప్పండి ఎవరండి మేడం ఆల్రెడీ నేను హ్యాపీ బంద్ చేసి 2 నెలలు 3 నెలలు అయింది అగైన్ అండ్ అగైన్ వై డిడ్ యూ కాల్ అంటే ఒకరు ఆఫ్ చేశారంటే బెస్ట్ ఫెలో ఆఫ్ ఇండియా ఓకే సో this anion always bigger than cation. Why? In anion electron is greater than proton, but cation proton is greater than electron. Therefore cation size is always smaller than anion. Already you know that point. But due to attraction my anion gets distorted. Distorted means they symmetrical nature become unsymmetrical. Unsymmetrical mean electron density is not distributed equally. It is coming towards the positive charge. But not completely to the positive charge. That means electron density comes between the cation and anion. So electron density comes between two nucleus is called indirectly it is a covalent character. Is it correct or not? Whenever electrons are between two atoms, electron pair is shared between two atoms is called covalent nature. Here in cation anion electron density comes between cation and anion indirectly to a covalent character is developing. Yes or no? So this is called polarization. Who done this one? Cation done this one. That is called polarizing power. This is called polarizing power. Who undergoes this one? Anion. That is called polarizability. So okay, as this is increasing and as the polarization increasing for a ionic bond covalent character increases. Yes or no? So as the polarization increasing covalent character increases. Okay na? So why do that? Covalent ionic bonds having covalent nature. This is the reason. Why do that? 100% ionic bond is not there. Why? Because every cation always attracts the electrons of anion. Due to that, they are not 100% to the anion. They are in between the cation and anion. A little bit covalent nature will be present. That is the reason why. Therefore, no 100% ionic bond is present. Every cation behave like this. But which is more, which is less, depending upon the cation size and anion. Yes or no? So polarization depends on polarizing power of cation and polarizability of anion and polarizability of anion. Sorry, again, polarizing power of cation depends on directly proportional to charge on the cation. Cation charge is more will be the attraction. Size, small size. If it is small size, more attracts the electron. Polarizability of anion, yes, charge, more the charge, more will be easily attracted by cation. Next, size, anion size should be big, if then only it is closer to cation. So is it the conditions opposite to the ionic bond formation? You see, yesterday, I think day before yesterday, I given opposite to the ionic bond formation conditions. Therefore, as the polarization increasing, ionic bond covalent character increases. Polarization depends upon polarizing power of cation, polarizability of anion. So always cation having polarizing power, always anion having polarizability. This polarizing power directly proportional to charge, inversely proportional to size. Directly proportional to charge, therefore, okay, larger the cation, smaller the cation size, okay, smaller the cation size, more will be the covalent character. Larger the anion size, more will be the covalent character. Smaller the number 3, charge. Higher the charge on cation and anion, more will be the covalent character. Is it opposite to the ionic bond formation? Yes. For a cation, a large size. For a anion, small size. Charge, small. For cation and anion formation, they are opposite. That is why covalent character increasing. If they are opposite, covalent character increases. More will be the covalent character. First point, second point, third point, fourth point. Cation having no noble gas configuration. ORR, pseudo-octet configuration has more polarizing power. And what is the meaning? More is the, what is the covalent character? These are called Fajan rules. And Fajan rules explain the polarization, indirectly explain the covalent character. This is 4 marks question in your IPE also. Smaller the cation size, larger the anion size, higher the charge on cation and anion will be increases more covalent character. And simply opposite to ionic bond formation. Understood everybody? Over. Our logic is over. So today the total lesson. What do you remember? In the today lesson, polarization only you should remember. Polarization is directly proportional to charge on cation and anion. Inversely proportional, directly proportional to size of anion. Inversely proportional to size of cation. Okay. If you know this one today lesson, enough. This polarization is equal to covalent character. I am not saying covalent bond. Please remember, Your Honor. Covalent bond means 100% covalent bond will be present. Covalent character, and a covalent character increases for a ionic bond. That is the meaning. They are not completely sharing. Still they are ionic bond, but a little bit covalent character increases when the covalent part is depends upon these points. Let us consider one example. Now for your convenience, NaCl, NaBr, NaI, all are ionic bonds. All are ionic compounds. Yes or no? All are ionic compounds. But which is more ionic? Is it all are 100% ionic? No. Ionic nature. Yes. Covalent nature. Opposite. Why covalent nature is opposite? Why nana? Left to right. Size of anion increasing. Why? Because I can't differentiate by +1, -1, +1, -1, +1, -1. All of them cation is also same. Who is only different? Anion. As the size of anion increasing, polarizing power increasing. Polarizability increases. As polarizability increasing, covalent character increases. Is our answer? So tell me, which is more ionic? NaCl. Which is less ionic? NaI. Therefore, more soluble in water, more soluble in water. That's why less soluble in water, less soluble in water. Correct or wrong? Understood the reason? I think today I have given the explanation regarding for you. Mister, tell me anyone doubt? Varun Kumar.
Sir, please explain the relation between the solubility of some salts and if same cation is present in their anion.
Sir, that is a 1 hour topic. After completion of this, I want to explain actually solubility, melting point, boiling point, conductivity. Understood, mister?
Okay.
These are required 3 hours now. Why do I am not explaining now mean? First I want to explain this one. There are some exceptions are there. Why do that exceptions arises? Because of this reason. I want to show that point. Understood, Mr. Varun?
Okay, understood.
While I am writing solubilities, while I am writing conduction, while I am writing, what is that, Nana?
Melting points and boiling.
Melting point, boiling point. Exceptions are arises. Those exceptions can be known only by polarizability and polarizing power. Okay, na?
Okay.
Chandra Sai.
Sir, why are they more soluble in water, sir? NaCl.
Hey, why? Ionic nature.
Okay.
Ionic compounds are polar. Polar soluble in polar.
Okay, okay.
ఈ డాషు నీలాంటోడే రామాయణం మొత్తం విన్నాడంట, రాముడికి సీత ఏందని అడిగిందంట.
Yes, sir.
ఏమైందిరా? చెల్లైంది కదా. ఆకాష్ కుమార్.
Sir, can you explain the last point, sir? Because my internet connection was gone, sir.
ఓకే, శివకుమార్.
Sir, water is universal solvent, no, sir?
Yes, 100%.
So, sodium iodide has to be dissolved in water, no, sir?
నేను అసలు డిజాల్వ్ కాదని చెప్పానా, లెస్ సాల్యుబుల్ అని చెప్పానా?
Sir, less soluble.
మరి క్వశ్చన్లోనే రాంగ్ ఉంది చూసుకో.
But it is soluble, no, sir?
Why not? Less soluble, that is why I wrote. And I wrote not soluble. Sir, universal solvent గా అని చెప్పి బెంజిన్ తీసుకొచ్చి వాటర్లో వేస్తే కరుగుతుందండి? Is it soluble benzene in water?
I don't know, sir.
Petrol, is it soluble in water?
No, sir.
Your water is a universal solvent, na? What you said is correct, na?
Yes, sir.
Tell me, you said water is a universal solvent. Shall I use petrol to dissolve in water? Rubber, no, you take rubber and dissolve in water. Is it rubber dissolves in water? But rubber dissolves in benzene.
Yes, sir.
You take naphthalene ball. Naphthalene ball, is it dissolves in water? But naphthalene ball dissolves in petrol. Why? That is called like soluble in like. Like means polar soluble in polar, non-polar soluble in non-polar. Even though water is a universal solvent, it cannot dissolve all of them. Is it stones dissolved in water?
No, sir.
It is a universal solvent, na? What you said?
Yes.
Don't say. Now,
yes.
What is the thing? Lastly, I said left to right, ionic nature increases. Why, Nana? Left to right, size of anion decreasing. But left to right, covalent nature increases. Why?
Yes.
Why? Because anion size increasing. Anion size depends upon polarizing power. That is the point. Now, sir, is there any effect? Polarizing effect? Yes. Now you see effect of polarizability or polarization. Effect of polarization on properties of ionic compound. This is the reason why I have explained this first. Effect of polarization on properties of ionic compound. Yes, first one. Covalent nature increases. Because of covalent nature increases. Second point, lattice energy decreases. Third point, lattice energy decreases. Third point, melting points decreases. Fourth point, what is that? Hardness decreases. Fifth point, okay, solubility in polar solvents decreases. Polar solvents decreases and non-polar solvents increases. Oh, sorry, meaning మారిపోద్దాం మీకు. And solubility in non-polar solvents increases. Next, sixth one, ionic conduction or electric conduction decreases. Electrical conductivity decreases. Electrical conductivity decreases. And seventh one, what is that? Colors intensifies. Colors intensifies. Okay. And eighth one, last one, acidic nature of oxides increases. Acidic character, okay, of oxides increases. Generally, in previous class, and up to 10:30, what I told you, ionic compounds having high lattice energy, lattice energy decreases. They don't have, what is that, covalent nature. Melting points are very high, now they decreases. Their ionic compounds are more hot, but they decreases. Generally, ionic compounds should soluble in water, but sodium iodide soluble in non-polar solvent. That means solubility in polar solvent decreasing, solubility in non-polar solvent increases. Electrical conductivity generally should be high, but they decreases. Colors should be less for ionic compound, but colors are increasing. Acidic nature, ionic compounds are metallic compounds. Their oxide nature basic, but they become acidic. What is the reason? All of them, polarization is the reason. Ante polarization is, it affects the lattice energy. Polarization, it affects the solubility. That is the reason why I didn't discuss about the solubility everything previously. Okay, na darling? Tomorrow, even though time is what is it consuming, I will discuss 1.5 hours this solubility, melting points, lattice energy, solubility, electrical conductance. Once again, okay na, they are the very important. Abnormalities are there. Why do that abnormalities arises? Due to polarization. If I tell polarization directly, you can't understand. That is the reason why today I have explained polarization. Okay na, we will discuss all these things in the next class. Now, who is the Divit Reddy? Tell me. Divit Reddy.
Sir, that fourth point show, sir, Fajan's rule.
Fajan's rule, fourth point, what is that? Octet configuration. Cations
Sir,
have no noble gas, or pseudo octet configuration has more polarizing power.
That
Why?
means
Listen. Octet configuration causes more shielding.
Yes, sir.
Octet configuration causes for a cation more shielding. More shielding means less attraction. Less attraction on anion. That is why polarizing power decreases. But if they have no noble gas or pseudo octet configuration, okay, they have more polarizing power. Understood, mister?
Okay, sir.
That is effective nuclear charge increases.
Sir, but in book, given cation with 18 electrons in outermost shell bring greater polarization.
That is called pseudo octet configuration, na? That is only I wrote.
Yes, sir. It should be or it should not be, sir, to get more polarization.
That is why I put to R.
18 electrons should be, na, sir.
Otherwise, okay.
There no your.
Okay, wait for your convenience. I am writing.
Okay, sir.
Cations with no noble gas configuration and with, is it better?
Okay, sir.
Is it clear now? If noble gas configuration, what happened? It has more shielding. More shielding means less attraction on anion. Okay, na?
Okay, sir.
I think time is up. Other students, sorry, very, very sorry. But Divit Reddy asked that is correct. And this giving a wrong information. Okay? Pushko, darling, bye.
inside my own world of make-believe. Kids screaming in their cradles, profanities. I see the world through ice covered in ink and bleach. Cross out the ones who heard my cries and watched me weep. I love everything. Fire spreading all around my room. My world's so bright, it's hard to breathe, but that's alright. Hush. Tape my eyes open to force reality. Why can't you just let me eat my weight in glee? I live inside my own world of make-believe. Kids screaming in their cradles, profanities. Some days I feel skinnier than all the other days. Sometimes I can't tell if my body belongs to me. I love everything. Fire spreading all around my room. My world's so bright, it's hard to breathe, but that's alright. Hush. Content, hold your breath and feel the tension. Devils hide behind redemption. Honesty is a one-way gate to hell. I wanna taste consumption. Breathe faster to waste oxygen. Hear the children sing aloud. It's music till the wick burns out. Be carefree lately, yeah. Just picking up daisies. Got one too many quarters in my pockets. Counting like the 4-leaf clovers in my locket. Untied laces, yeah. Just tripping on daydreams. Got dirty little lullabies playing on repeat. Might as well just ride around the nursery and count sheep.